Morning, teacher.
Morning. Was that Victor? Good morning to you. Thanks for joining me. All right, so here's our objectives today. The lesson is called literal equations, literal with a T. And our objective is to solve equations that have many variables in it. So literal equations, and our objective is to solve equations that have more than one variable in it. Hang on one second. A little lag here. There we go. All right, so literal equations and the kind of equations we'll be looking at have more than one, and we still solve for just a single variable. We can only solve a variable, or it's only useful to us to solve it so it has one variable, one letter all alone. Here's a quick example of what I mean, and we'll look at some actual examples in a moment. So here's what I mean. Maybe we have an equation like this: x plus y equals 3 minus a. So this is an example of a literal equation. And we call it that really just because it has more than one variable, and we don't know what those numbers are. We don't know what x or y or a is yet. Maybe in our problem we do. We get told to plug in a value for one of them. Maybe we don't. But we can still treat these variables the same way we treat regular numbers when we're trying to solve the equation. Any questions or concerns right now before we move on? Please. Okay. And just a quick reminder, if anyone needs to miss today, if there's any issue with like class today, go ahead and message me privately on Remind or like an email, and I'll see that message. But I can't do a quick breakout session. I want to get going because I was a little late. So forgive me. I have to put that off. And if there's an emergency, it's okay. Take care of your business, and we'll work it out together, like when we can. Okay, a few reminders to everyone about solving an equation. We've been doing this for a few days. This is solving an equation. So a few reminders. We want to isolate a certain variable. When you hear solve an equation, this is what we mean. We mean isolate, get it alone. Usually it's like get x all alone, right? Or get y all alone. How do we do it? Identify what operations are happening to the variable, like adding or subtracting or multiplying or dividing. And then we do the opposite to both sides of the equal sign. This is my steps on how to solve an equation, just some hints. So for example, folks, if we were given an equation like this, a one-step small equation, x plus 7 equals 30. My goal is to isolate x and solve it for x so that x is all alone. How I can do that is identify what's happening. What's happening here is it's plus 7. What's happening to the x? It's plus 7 to the x. So what's the opposite of plus 7 that I'm going to do to both sides? Anybody want to take a stab at this? How I could solve this for x?
Subtract 7.
Anaya, high five, thank you. Yeah, if you identify what's happening as plus 7, Then think to yourself, what is the opposite of plus 7? It's minus 7. Subtract 7, like she said. We do that to both sides, and then we can solve it. X is, nope, not 21, 23. I said 21. Okay. So I just wanted to go over those again with you because we're going to be using this same approach for all of today's problems. But it's going to look a little more complicated because we've got more than one letter. We've got more than one variable going on in our examples. Here we go. Let's try this one. Example 2. So here's a proper literal equation because it's got x, b, and a in it. And the instructions say solve the equation for x. So whenever we have one of these problems, folks, a literal equation basically with more than one variable, I want you to look for the specific instructions. What are we solving for? Which letter do we want to solve for? Here it says x. Maybe it could have been a different question and they asked us for b or a. So it's important to know what we're trying to solve for in the first place. So I'm solving for x, so I want to identify what's happening to the x. So I'm going to make a little list off to the side here. What's happening to the x? 2 is being multiplied. To the x, and I see that b is being added. So that's 2 being multiplied and b is being added. The reason we're doing this is to figure out how we undo those things and then ultimately get x all alone, isolate the x. So I've done step 1. I've gone through and identified what's happening to x. So now I'm going to undo those actions. Frankly, I don't want to make it confusing, so forgive me if I am. Honestly, folks, it doesn't actually matter which order we solve the equation, which thing we undo first, whether we want to undo the 2 being multiplied or the b being added, but it does make it easier if we work from farther away and get closer to the variable one step at a time. So out of the 2 and out of the b, out of those 2 items, the b is farther away from x. So I'm going to start by undoing that plus b. So I have to say minus b to both sides of my equal sign. Now, the issue of like terms is gonna matter here. So on the left side of the equal sign, we have 2x plus b minus b. Like terms are b and b. Excuse me. So those can interact and cancel, right? Plus b minus b goes away. We're left with 2x on the left of the equal sign. But on the right, I've got a minus 10 minus b. There are no like terms here on the right side. A and b can't add or subtract, and the 10 can't add or subtract with either of them. What should we do next? We have to undo times 2. So I'm going to do divided by 2 because that's the opposite of times 2. And if I do it to the left, I've got to do it to the right. We want to do it to both sides. So this can be tricky, but pay attention. The whole right side is being divided by 2. So I'm going to draw a division bar under the whole right side and then put my 2 underneath it. So that's a minus 10 minus b, that whole quantity divided by 2. And what are we left with? X equals a minus 10 minus b, all divided by 2. And there's our answer. We've solved it for x. There's a message in the chat. Okay, it looks private, so I'm going to put that back. I'm sorry. Hope everything's okay. Take care of your business if you need to leave class, and we'll work it out together later. Any questions on this example 2 and solving for x here? Please, comments, concerns. Okay. No questions. I'm going to try another example with you then. Example 3. Solve the area of a triangle formula for B. Okay, so they're telling us that this is the area of a triangle formula. We have A equals 1/2 times B times H. B stands for the base, H stands for the height, and A stands for area. And this is the area of a triangle formula. But we're not trying to figure out the area of any triangle. We're just trying to rearrange this and solve it for B instead of right now it's solved for A area. But I want to undo what's happening to the B and get it all alone. So, this time I'm going to let you guys try this out. And if I could have someone willing to share after they've tried to solve it, and if you don't mind sharing with me and the group, we'll talk about it. So go ahead and give this a shot. I want you to try to undo what's happening to the B, solve for B, and let me know what you get, or if you have any questions on the process. All right. Did anyone simplify it down a little bit? Was anyone able to do the first step or a second step? Anything at all? Any thoughts on it? Any concerns on this question? Or did anyone finish it and want to take a stab at answering it? Okay. All right. It's okay. I'm hoping everyone's at least given it a shot and not just waiting. And that's okay. But let me know if you have any questions. Let's talk about this one. This one is a little tricky. It's a little tricky because it's got 1/2 times B times H, right? Um, so when I multiply this half times B and H, you can think of it as a half times it. But another thing is that I could kind of combine the half, the B, and the H all into one like division, one fraction. So here's what I mean, and this might make it a little easier to see how to get started and solve this one. So if I were to multiply 1/2 to B, that would be B over 2. And then there's still the times H, right? But H times a fraction is going to be H times the number on top, just like B times a half was. So we have B times H all over 2. Essentially, it's B times H divided by 2. Now, we haven't solved it, but that's the same thing. So now it might be a little easier to see what's happening to the B. what operations are happening to the b so we can undo those operations. So I see that b is being divided by 2. So that means we need 2 times 2 on both sides. So let's start with that. So we have 2a is equal to bh. The 2 over 2 on the right canceled out. All right, and I want to solve it for b. So what's happening to the b right now? It's being multiplied to h. So how do I undo multiplying by h? I want to divide both sides by h. So on the right, h over h cancels out because anything divided by itself is 1. So we have b equals 2a over h. I see something in the chat. Is this? So thank you for that comment in the chat. Remember, we weren't trying to find the area. We were just all we wanted to do in this case was solve the formula for b. We want to rearrange everything so that b is by itself. Right now, how it started at the top, a was all by itself. A was isolated. We wanted to change it around so that B was isolated. How we do that? We're going to use the same rules and procedures that we use to solve a normal equation, an equation with just like one variable in it. So even if it has more than one variable, we're just going to treat it the same way as if they were numbers. So I had to divide everything by, I had to multiply everything by 2, and then I had to divide everything by h. And then finally, I got B all alone. I hope that was helpful. Before I do any more, I'd like to see thumbs. I want to see where people are at right now with this concept. So I'm going to come back to my whole view here. And if I could have you give me some feedback, let me know how you're feeling about these problems. Example 1 and 2, 3. So remember, thumbs up means you're feeling good and confident right now. And thumbs sideways is I'm doing okay, but I need more practice. And thumbs down means we got to keep going and I need more practice and I need some explanation. Maria, I see that. Thank you for your feedback. Victor, appreciate the feedback. Thank you for showing me. Anyone else, please? Is everyone else here besides Maria and Victor? Are you guys actually with me? Anaya, thank you for your feedback, Anaya. I'm glad you're following along. Thank you. We're going to do more practice. I hope it's helpful. All right. Now I'm a little concerned that people are just like checking out. Except for the 3 of you who did actually respond. I appreciate that. Madison, I know you just joined us, so you can't give feedback. Okay.
I was gonna say I don't know if I should give a thumbs up anyways
No.
because my Wi-Fi was acting up.
Yeah, no. You joined late. It's okay. I'm glad you're here. It's better than not at all. Savannah, thank you for the feedback. I appreciate that. I just want to know where you guys are at, how you're feeling about it so far. All right, well, let's look at another one then. Let's go back and look at more. Remember, the goal of today is just solving equations, but they have more than one variable, more than one letter, like this example 3 did. Let's look at another one. All right, I did make it more confusing on purpose. More parts, more things going on. They're going to get confusing as we keep going through math. So we have to start that, practice now. Solve the equation for C. So let's check out what we got. We've got B equals A minus C over 2 plus D. So there's 4 different variables here. We know we want to get C all alone. So we want it to say C equals stuff. C equals all this other stuff. And once we get to that point, we're done. But we have to get it to that point. So we want to undo everything that we see happening towards that C. So first off, I see plus D, right? Plus D, that we'll have to undo that by minusing D from both sides. I see underneath my C, the letter C, I see divided by 2, right? So that means we're going to have to multiply everything by 2 to make that division of 2 go away. And I've got A minus C. So we're going to have to get that A to leave. I think we'll have to subtract an A to get the A to go away from C. And then lastly, it's negative C that we have. It's minus C. So we're going to want to do something to change that to positive C. We're going to want to multiply both sides by -1. But there's kind of a list of all the things that are happening, quote unquote, to the C. So we want to undo the A, got to undo the 2, and got to undo the D, and we have to undo that negative sign to the C. That's kind of its own thing. It's a fourth thing. So it can be confusing how to start, but remember, try to find the farthest away item from the variable that we're solving for and do that first. The farthest away item here could be the 2 or the D. I think the D looks farther away, so I'm going to start with that. So minus D on the right side and minus D as in dog on the left side. Now remember, like terms, so B minus D on the left cannot be simplified or added together or subtracted. They're not like terms. So we've got B minus D equals A minus C over 2. And then plus D minus D, that was the whole point. They cancel because they are the same like term. Any questions on that first step, please? All right. Oh, wait, go ahead.
Question. So it's basically like doing the same with the numbers, just with letters.
Got it. That's it. It's the same as with numbers, but with letters instead. Exactly. So now what's up with C? Well, it still has the A we have to get rid of, and it has the divided by 2. Let's do that divided by 2. We're going to multiply by 2 to cancel out the division. I've got to do it to both sides. So you can think of it as multiplying everything on the left by 2. I'm going to group these together, B minus D. I'm going to group those together with a parenthesis and then multiply that parentheses by 2. This way, it's a little cleaner, and I don't have to write as much, and it's still doing the same thing. I've multiplied the left and the right by 2. So we've got 2 times B minus D equals A minus C. All right, since A is positive, and it's like minusing C. You see that? It's subtracting C. I want to undo that with a minus A itself. It's a positive A, right? So what would I want to add to that? I would want to add a minus A. So I'm essentially subtracting A from both sides. Okay, it's almost done. C's alone, except it's not positive C, it's negative C. So to fix that, we're going to multiply both sides by -1. So imagine multiplying a -1 on the right and to everything on the left. So I'm going to write them this way to show that. Now, when I multiply -1 to everything, what's happening is everything's just getting its sign changed. All the positives become negative and the negatives become positive. Because remember, a negative A times -1 is going to be positive A. So finishing this off here on the right side of the screen, we've got a positive a, we've got a minus 2 b minus d, and equals c. So that was many steps. That was our toughest one yet because it was such a big equation to start with. But we did what we were supposed to do. We got c alone, isolated. C equals stuff. C equals a minus 2 times b minus d. Any questions? Concerns? I've got like 2 or 3 more examples, and then and some of these examples you're going to see next are like straight from the mastery test, so you can see the format. And then we're going to take our next mastery test. So I hope I'm trying to get this done fast, like maybe 5 to 8 minutes, and then we'll have 22 minutes to do the mastery test together. All right, so here we go. I did pull this one straight from the mastery test. Now, I realize that sometimes word problems can be scary because it's a lot of writing and it's easy to kind of get lost in the writing and not really know what it is do they even want? What is it that I'm looking at? So like our other word problems from last week, let's do our best to read through it, try to figure out what it is they want, and then we'll read through it again. Consider the formula for the average velocity v of a moving particle. In the formula, d1 and d2 represent the distance traveled by the particle at times t1 and t2 respectively. Okay, and then we get a formula. V equals d2 minus d1 over t2 minus t1. Which of the following equations is equivalent to the formula for velocity? So what they're asking us in this problem is which of these options, A, B, C, or D, is equal to the one above, is equivalent to the one above. So how do we even go about finding this? Well, notice that our options, we have A, T2 equals, B is D2 equals, and then the next two they're different as well. So what we're going to do is do our best to quickly solve the original equation, V equals. We want to solve that for the other variables. And only one will match up when we solve ours. Only one will match up with A, B, C, or D below. Basically, they're asking us to solve the V equals, the velocity formula, 4 times. They want us to solve it for D2, D1, T2, and T1, and then match that up with our options below. So let's just do this. I guess I'll do it in order of A, B, C, or D. So let's, for A, they're solving for T2. Right here. Solve for T2. So I'm going to write down the velocity formula and then solve it for T2 and see if it matches up with option A. So here's our original formula. D2 minus D1, and then T1. Okay, so we want to solve for the T2. So this one's hard because we've got, it's T2 minus T1, and it's in the bottom of a fraction. So how do we deal with that? And actually, this is the first time I've done this with you guys as a group. So how do we get that T2 and the T1 out of the fraction denominator? Well, here's how. We're going to multiply both sides by that entire denominator, okay? Just as if that was a single number, I'm going to multiply the right side by T2 minus T1, like this. And the left side gets multiplied by that whole subtraction. On the right side, T2 minus T1 over the same thing cancels out. That's why we did that. So now, I guess I'm going to multiply the V, distribute the V. I'll do that below. So we have V T2 minus V T1 equals D2 minus D1. Now we want to solve for T2. We want to solve for this guy right here. So let's get the other term to go away. So we're going to add VT1. So we've got V times T2 equals D2 minus D1 plus VT1. And then last step, we want to divide everything by V. Yeah. So that comes out to T2 is equal to D2 minus D1 over V plus, so for this part, notice that we have V, T1, like together. I'll show you in 2 steps here. If I separated that division, that fraction, it would be VT1 over V. But V over V is 1, so those can cancel. So it really is just plus T1. So our T2 is equal to this whole thing plus T1. Now, looking back at option A, it's not the same, right? What we have is D2 minus D1 divided by V, and they have it as times V. So that means A is not correct. So we have to try the other 3 and see if we can get a match. Let's see. I think based on what I just saw, I think that if we solved for T1, option C, that we're also going to get a division. It'll be D minus D over V, like last time. So I think we can probably safely assume it's not option C either. But let's try solving for D2. Let's see what we get there. Hang on. The original is V equals D2 minus D1 over T2 minus T1. And let's try solve. I'm going to write this down. Solve for D2. Okay, so I want to get my D2 all alone. So we start by multiplying the top or the left and right by T2 minus T1. Okay, so my whole fraction goes away. That's nice. And now it should look kind of familiar to our options. We get a multiplication instead of that division. We have T2 minus T1 times V equals the subtraction, D2 minus D1. All right, I'm solving for D2, so we're almost done. We just add a plus D1 to both sides. And what do we have? D2 is equal to the V times T2 minus T1 plus D1. I think that was one of the options. Let's double check. T2 minus T1. Yep. So it actually is this option B. So unfortunate problem because we have to do a bunch of solving. It's like 4 problems in one. And it's kind of confusing because D's and T's and 1s and 2s, it all kind of blends together and looks the same. But I'm just solving it for one of the letters or one of the variables, one step at a time, just like they were numbers. And make sure to get this down on paper because this one is on the mastery test. You may end up getting this question. All right, any questions or concerns on example 5, please? No. Okay. All right, this is my last one to do with you. So consider the equation 5 times E times F plus 2, and that's all in a parentheses, equals 100. And then they give us this. The value of E in terms of F is what? And then the value of E when F is 6 is what? So I wanted to talk about this writing in terms of when you see this in this mastery test or any math work ever, E in terms of F, what they mean is solve for E. That's what that is code for. The value of E in terms of the other variable, it just means solve it so it says E equals stuff. And we have to figure out what is that stuff. The in terms of F, that means that the stuff will have an F in it. It's the other variable or the other variables will be in the other side. So if you see that phrasing, E in terms of F or a number in terms of a number, basically the first one you see, we solve for that. So what they're asking us to do here is write this as, excuse me, E equals the stuff. So let's try solving it. All right. I've got E times F plus 2, and then that's all multiplied to 5. I want to get rid of all that stuff and get E all alone. Ideally, I could undo my times F and my plus 2, but because they're trapped in that parentheses, I want to get rid of that parentheses first. So to get rid of the parentheses, I need to get rid of that times 5. So I start this problem by undoing the times 5. We're going to divide both sides by 5. And we get EF plus 2 is equal to 100 over 5, which is 20. Now we want to undo the plus 2, so I'm going to subtract 2 from both sides. And we get EF is equal to 18. And we finish up by dividing F because I want to get E all alone, right? So I want to do divide by F, and we get E is equal to 18 over F. So there's my answer. That's E in terms of F. So I'm going to put that up here in the box. And also, if we're typing it into Edmentum, then you can type it in as just 18 over F. Now, this problem isn't exactly in Edmentum. I changed the numbers, but there's a couple problems like this. So what you type in is like what E is equal to. Then they say, what is the value of E when F is 6? Well, that means we're going to plug in a value for F now, simplify. So 18 divided by 6 is 3. So then my answer is 3. I solved it for E, and then they gave me a value to plug in for the other variable, and then we just simplified. Okay, those 6 examples should cover everything we're going to see in today's mastery test. So, just like Wednesday, just like last Thursday, I want everyone to log into Edmentum, and if you haven't already, get started on today's new mastery test. It's called Literal Equations. Literal Equations. Same name as this lesson and video. And we've got about 17 minutes left together. So honestly, to do 5 questions, I'm hoping we can get through everyone's mastery test today. If you're logged in, if you're started, and if you have questions, let me know. Tell me the problem, read me the problem, and we will do it together.
Hi, Josiah.
Levi, thank you for joining. I'm sorry right now, I just finished the lesson.
Yeah.
So I'm glad you are doing okay and you're here. I'm going to go ahead and put you down as like you came a little late, but you're here. And
I wanted to apologize for that. Sorry.
That's okay. I appreciate you coming and saying sorry. That's really nice of you, and mad respect for that. Thank you. Don't worry about it. No hard feelings on my end, but I do want you to check out my video as soon as I can get it posted this afternoon, and then try doing it on your own, okay?
Yeah, of course.
And then today's homework is the next mastery test. It is called Literal Equations. That'll be the name of the video too.
Okay, thank you.
Awesome. Thanks, Levi. You can go ahead and go now. That's okay. Unless you want to hang out and see if any questions are asked. But otherwise, you're free to go. No big deal.
I think I'll stay.
Okay. Awesome. All right. So everyone else, let's log in and start that mastery test. Or if you have questions on the examples from today, let's talk about those. Let me do this. Turn my recording back on. All right, so Maddie, CX equals 7. So the name of the game here is we're solving for X. I'll write that down. And like you said when you joined, we're basically doing the same thing as last week, except we'll have more than one like variable, more than one letter. So what I want you to do is focus on the X and what other items, what other operations are happening to the X that you can see here. So for instance, go ahead.
Oh, it was being subtracted.
Yeah. What is being subtracted?
X minus 4.
Totally. That minus 4 is an issue for us. Anything else happening to the X?
The C.
Yes. What's happening with the C? Is it subtracting, dividing, multiplying? Multiplying. So we're going to undo times C. Let me write this down just in case it's helpful for you or anyone. We need to undo the timesing of C, the multiplying of C, and we have to undo the minus of 4. So let's do that. Let's undo timesing C and undo minus 4. I'm trying to encourage everybody to do the farthest one from X first. So out of C and 4, which one looks farther away to you?
The negative 4.
The negative 4. So let's start by adding 4 to both sides. This is doing the opposite, right? Doing the opposite of the stuff we identified happening to X. And what does that leave us after we do the plus 4 to both sides? We have CX
Equals 11.
equals 11. Thank you. So now you already said it's C times, so we want to do a what to cancel that? Divide. And I think we did it. We've got X equals 11 over C. You might need to type in 11 over C as 11/C, and that should be your answer. 11/C. Unless it's one of those questions where it has like all the tools, in which case you can do a fraction is 11 divided by C. Madison, does that help? Any other questions?
Yeah, it helped.
All right, awesome. Thanks for asking. If anyone else has a question, let's go over that together. We've got about 8 minutes left.
I have a question.
Please. Go ahead with your question, please.
Oh, okay. I guess I'll just read it.
Okay.
It said solve for R, but it says A equals V2 over R.
A equals V. Is it V times 2 or is it V with a little 2 above it?
Like above it.
Okay. Over R. And then they said they want us to solve for R. Is that right?
Yeah.
Okay. Anaya, come check out my screen, would you?
Okay.
Do I have that down the way it looks on your page?
Yeah.
Okay. Okay, so very good. Thanks for sharing and reading that to me. So A is equal to V to the second power. That's how we read that. That's the exponent, 2. So V to the second power over R. So the good news is we just need to get R alone. And R looks a little easier to deal with than that V to the second power because it's got the 2, right? We don't want to deal with that if we don't have to. So to get the R alone, I want to get it out of the fraction first. It's got to be all alone. So if it's being divided, how can I cancel out that divided by R? Is there anything that comes to mind that cancels out with division?
Multiplication.
Very good. So I'm going to hit both sides with times R like this. Now on the right, with the V to the second power, we have R over R. Those cancel. And on the left, we've got RA or R times A. I'll put the times in there. R times A. So what we have is R times A equals V to the second. Now, remember, we want to get R alone. So I've got to get rid of that times A. We are going to divide both sides by 8. And what are we left with? R equals V to the second over A. Now typing this, oh, you're welcome. Does that help? Any questions?
Yeah.
Okay. To type this in, if they give you the toolbox, the tool, like the math tools there, some problems have it. I don't think some do. To use the tools, there's a little exponent button you can push. So you'll do your V, then you got to do the exponent button. And I think the exponent button looks like an X, Y, or something like that, X to the Y with a little number above the X. Hit that and then type your 2, and you should get V to the second power. If you need help with that, let me know. We can share screen, and I can try to walk you through it that way.
I think I found it.
Okay, nice job, Anaya. Anyone else want to ask a question right now, please?
I need help with another one.
Okay.
It's like the kind of like the other one of the other ones that we did.
Okay.
But what's really confusing me is the fact that the px plus 1 is in parentheses, and I don't know if I deal with the 4 first with multiplying it within the parentheses, or
I think I know what you're talking about. Would you mind trying to read the whole thing to me from left to right, the equation?
So it's 4, and then in parentheses it's px plus 1.
Okay.
And then after that it says equals 64.
Equals 64. Good. Okay. And I appreciate what you're saying. You're saying, I don't know to start with the 1 or the p or the 4. What are we solving for? Is it p or x?
Whoops, I thought my mic was off. It says the value of x in the term of p is, and then it says the value of x when p is -5.
Okay, thank you. So what they mean by that, and I'm just going to write that down quick, the value of x in terms of p, what they mean by that is solve for x. Okay, I'm going to write that down here. And flip back to my screen, Maddie, if you haven't already. Solve for x. So whenever you see variable in terms of variable, the first one is telling us what to solve for. They want us to write x equals stuff, numbers with p on the other side. So it'll be x equals all the numbers with p, the second variable. Okay, so they are telling us we want to solve for x. And now the question is, well, what do we start with? Well, because we've got that parentheses and x is inside it, I basically want to get it out of there. But I guess there's two ways we could do this, Maddie. You could start by actually multiplying 4 into the parentheses. So 4px plus 4. But I think we can save ourselves a step if we, instead of multiplying that in, if we get the 4 to go away completely by dividing it out from both sides. So here's the original problem. We're going to start by dividing 4, because it does say 4 times like the parentheses, right? And x is in that parentheses. So we are undoing something that's happening to x. If you think about it that way, we're undoing the times 4. So we've got px plus 1 equals 64 over 4. I think that's 16. Thank you. And now what do you think we might do? We've got p times x and we've got plus 1.
Subtract the 1 from each side.
There we go. Good, good, good. Yep. So you've got px equals 15.
And then you would get rid of the p, right? By dividing the p from each side.
Very good. Very good. So you've got 15 over p, basically. All that work boiled down to just x equals 15 over p. So that's your first answer. X in terms of p is 15 over p. And I think what you need to do, Maddie, is the / for your division bar. 15 / p. The second question, they're saying, what is the value of x when p is equal to some number? So that means you're going to plug that number in for p and do 15 divided by whatever.
Negative.
Yeah. And then you're going to type in your whole number answer once you get that. So the second question won't have any p's because we're plugging in a number for p, the -5 or -3. Okay, I just realized it's 12:01 on my computer. So I'm sorry I kept you guys too late. I hope everyone's doing okay. I didn't ask for notes today, and I'm not going to because it's already late. So have a great day. And if you haven't started it, you really should try to do your new mastery test, literal equations. I'll have up the video probably about like 1:30.
Thank you, teacher.
Thank you, Victor. Good to have you back today. Have a
Thank you,
great.
teacher.
Thanks, Robo. Of course.
I like it, teacher.
Thank you. You too.
Yeah, I like it, teacher. I love it.
All right, everybody. Have a good day. Maria, I hope you're doing okay. You had a question earlier and, a comment at least.
I actually need help with one more question.
Sure.
Do you want me to share my screen so you can see it?
Yeah, that's fine. Go ahead and share the screen. Okay. So they give us this confusing looking formula. V equals 1/3 times a to the second times h. And then which equation correctly rewrites the formula to solve for h? So basically what it's asking us to do is solve for h, and then it should match up with just one of those options below. Now, did you start this one yet or not yet?
Not yet.
Not yet. Okay. So go ahead and come back to the. Well, I'm going to stop you from sharing. I'm going to take over here, just to kind of get it set up. Okay. So let's see. It was volume equals, I think, 1/3. And my bad. I should have written it down. It was 1/3 something squared.
Have a good day.
Oh, you too, Philman. You too.
Nice cat here. Mhm.
It said 1/3 A to H.
Okay, thank you for that. So the 2, remember that's an exponent. Let me put that on the side here. A2, well, how we read that is A to the second power. Another way you might hear that referred to as A squared. A squared. Squared is kind of like a nickname for A to the second power. And what it means is A times A, basically. So whatever number has that little 2, what it means is the number times itself. So we want to undo all this stuff going on to the H. So let's start with the 1/3. It's 1/3 times, the A's times H. We want to get this 1/3 out of there. So if 1/3 is being multiplied, now we could think about it, Maria, as like dividing by 1/3 on both sides. And that's true, but it also makes it a little more complicated. So I guess I'm kind of twisting a rule here. Instead of dividing by 1/3, think about it like multiplying both sides by just that denominator, just 3. So if you start by multiplying everything by 3, then we have 3v. And then on the right side, we have 3 times all that other stuff over 3. Do you see that? Let me back up. All the things being multiplied on the right side can be put into the same fraction like this. So it's like 1 times A squared times H times 3. All the different numbers on top, the numbers that don't have fractions, get multiplied to the numbers on top of the fractions like this. And why can we do this? Because let me just do a smaller example to the right side here. Let's say we had 1/3 times H. Well, if this was the only stuff in our problem, how would I multiply these together? H needs to have you put a 1 underneath H, just like if it was a whole number, and then you multiply across the top and across the bottom. So we get H on top and 3 on the bottom. And that's what's happening with our actual problem back on the left side. But we've just got more stuff, right? We've got the 1, we've got A squared and H and 3. So all those top numbers get multiplied together on top. And then we get 3/3. But those cancel. And we did that on purpose so they would cancel. Now, 1 times A times H, we don't really need that 1 time. So I'm going to drop that, and we have now A squared times H. So now, Maria, since what's happening to the H is multiplied by A to the second power, then I want to divide by that whole thing, A to the second power. So treat it like it was its own like variable, A to the second power. If it was just an A, you would have divided by A. But since it's A to the second power, we just divide by that whole thing, the whole term A to the second power. Now they cancel. And H is equal to this, 3V over A to the second power.
Okay, that made a lot more sense.
Does that help?
Yes.
Okay. Any questions, concerns?
No, I think you explained it really well, actually.
Okay. I'm glad to hear. I hope so. I mean, I just get afraid that, people are just like, yeah, that's good enough, Josiah, hush. And then, like if you don't want to, so just always feel free, Maria, to tell me if it doesn't make sense or anything. Okay.
Okay. Thank you.
Yeah.